Today we're going to discuss graphing rational functions, and rational functions are basically just a function made up of the division of two polynomials. So you'll see over here on the left that I have some functions that have two polynomials division, and then on the right I have the graph of these two polynomials. These may not be the exact graphs corresponding, but they are rational graphs. And you'll notice these like dotted lines going on. These guys are called asymptotes. And there are two types, well, actually there's three types, but there's going to be two types we talk about today. One are vertical asymptotes. And what these do is they describe limits of domain. In other words, what values cannot exist in the function. And if I have a horizontal asymptote, these describe end behavior. In other words, as x gets big, what happens to y? And as x gets big, negative, what happens to y? So you notice in this case, if I were to describe the end behavior as x gets big positively and negatively, y gets very close to 1. In order to graph these, we have to go through a series of steps. We're going to find intercepts, find a vertical asymptote, and that's as simple in this case as setting a denominator equal to 0. Since these are all fractions, anytime we have 0 in the denominator, that would be a bad thing. So all we have to really do is find out when the denominator is equal to 0, and we'll have our vertical asymptote. Horizontal asymptotes are a little bit different. They describe the end behavior, and here are three keys to look for in order to determine what that horizontal asymptote is going to be. The book describes this a little bit different. I think this is a little bit easier, so I'm going to show you this. If you want to use the book's definition, knock yourself out. But if we have the degree of the numerator, which is the biggest power, less than the degree of the denominator, you've got a horizontal asymptote of 0. If the two degrees are equal, then you're going to take and divide the leading coefficients in each to get your horizontal asymptote. And if you notice you have a degree in the numerator, one greater than the denominator, there's not going to be a horizontal asymptote, but something called a slant or oblique asymptote, which we'll talk about tomorrow in part 2 of this discussion. Then we're going to sketch a graph using what we know, and if we need to, we'll plug in some points to complete the graph. So let's start out with a fairly simple example. In this case, find our x-intercepts. To find the x-intercept, set y equal to 0, and solve. Now in this case, it's kind of a little tricky. We solve by multiplying the denominator through. We get 0 equals 3. That's not a true statement, so there are no x-intercepts in this. It's not necessarily tricky, it's just out of the ordinary. All right. And then we're going to find our y-intercept next. My pen's freaking out on me. So to find my y-intercept, I'm going to set x equal to 0. In doing that, I get y equals 3/5. Vertical asymptote. We set the denominator equal to 0, so x plus 5 equals 0 in this case, and x equals -5. And in the horizontal, we look at degrees of the numerator. And actually in the numerator, I have 3x to the 0, even though you don't see x to the 0. And in the bottom, I have x to the first. Degree of the numerator less than the degree of the denominator, so y equals 0 is my horizontal. Now we'll take and plot some of this stuff and see what we've got, and see if we can analyze this graph from here. So I know I have an x-intercept that doesn't exist. y-intercept, let's call this 3/5. And I'll put a little dot right there. I have a vertical asymptote at -5. So I'm going to throw that line right here. I have a horizontal asymptote at 0. So that's going to be right here. Now, there's a couple of things I know about this graph. One is that it's got to go through this point at 3/5. So if it goes through the point at 3/5 and doesn't cross the axis, because I have no calculated x-intercepts, my graph has to move up here and it has to move over here. Again, it moves to the right because as x gets very big, y approaches 0. That's the horizontal asymptote. On the left side of this graph, I'm really unclear as to what it does. It could be up here, or it could be down here. So here's where I have to pick a point and see what's going to happen in that region. And the point I'm going to pick is -6. And all I really care about is what comes out, a positive or negative, because I need to know if I'm above the axis or below the axis, much like the inequality problems we did before. I plug it in. On the top, I've got a 3, so that's positive. But on the bottom, I have a negative, which gives me a negative value. Therefore, at -6, my value is negative. I have to approach both set of axes and can't cross the origin. Or not origin, but the x-axis. And that's what my graph's going to look like. Now, if we move over to our next example, all these will change just a little bit. I'll notice I have a variable in my numerator. X-intercept again. Find the x-intercept, set y equal to 0. Multiply the denominator through. I get 0 equals x. And that's my x-intercept. My y-intercept, set y equal to 0. Get 0 again. My vertical asymptote, set denominator equal to 0, so 2x minus 4 equals 0, x equals 2 is going to be my vertical asymptote. My horizontal asymptote, you'll notice I have x to the first, there's a 1 in front of that, and 2x to the first. Since my degrees are equal, divide the leading coefficients, and I get a half is equal to y for that horizontal asymptote. Now I'll go ahead and start sketching this. X and y intercept of 0. Y asymptote of a half. Vertical asymptote of 2. And in this case, I can say a lot about this graph because I know it only crosses the axis in one spot and it has to approach this line as x gets very big, and it can never touch this line. Therefore, it has to go down like this and over like this. And then on the right side, unlike the last problem where I didn't know anything about it, I know a lot about this. I can't cross this axis anymore because I have no more calculated x-intercepts. Therefore, the graph has to be in this region and approach both asymptotes because, once again, it can't cross the x-axis. You'll notice in this problem, I have a second degree on top and a second degree on bottom. I always take and factor that denominator out first, just because I know I'm going to need it when I set my denominator equal to 0 for my vertical asymptotes. So I'm going to do an x-intercept first. And you'll notice in the x-intercept, I've got 0 equals 3x squared over x squared minus 9. Denominator multiplies over. I get 0 equals 3x squared. So x equals 0. Y-intercept set x equal to 0. When I do that, I get 0 again. Vertical asymptote set the denominator equal to 0. In this case, I'm going to use the factored form. So that's x plus 3 and x minus 3. And you'll notice that in this case, I get two possible answers, plus or minus 3. That means I'm going to have two vertical asymptotes. Horizontal, degree of the numerator, 2. Degree of the denominator, 1. So y equals, since they're equal, y equals 3 is my horizontal. So let's go ahead and plot some of this stuff. Here's 3. Here's negative 3. Here's 3. Draw these boundary lines, if you will. Sorry, they aren't totally straight. Put in my intercepts. And now, again, I've got a lot of clues in this problem. I know this is the only place it hits the axis. Not anywhere over here, not anywhere over here, which tells me that in the leftmost part of this graph, since I can't cross this axis because there's no calculated x-intercepts, the graph has to be up here. Likewise, on the right side, the same thing's got to happen. I'm not crossing the x-axis anymore because there's no intercepts, so I have to be in this region here. In this case here, I don't know what the graph's going to do. It could look like some kind of a quadratic. It could look like a cubic here or a cubic here. And some of you guys are going, but how can it be a cubic if we're crossing that asymptote? Nobody said we couldn't cross a horizontal asymptote, only a vertical asymptote, because vertical asymptotes limit the domain. Horizontal asymptotes only describe end behavior, what happens to the graph when I'm very big negative or very big positive. Between 3 and negative 3 is not very big, so we can cross it whenever we want. So what I'm going to do now is I'm going to, again, pick a couple of points and check to see what's happening in those two regions. So I'm going to pick a value of negative 1 and a value of positive 1 to plug into my function and see what happens. So you'll notice on top, I have an x squared, so that's going to make everything positive. In the bottom, I've got a negative and a positive, which is a negative. So this has to go somewhere down here. And when I plug a positive 1 in, again, I get a positive. I get a negative and a positive, which equals a negative. So this is going to be somewhere down here. Again, these are just rough sketches. They're not exact, but that's all we're looking for. All right, let's take a look at this example now. You'll notice again, I have to do some factoring in my denominator. So this goes to x plus 5, x minus 1. Intercepts. Again, set y equal to 0. So in this case, multiply the denominator, get 0 equals x plus 7. X equals negative 7. Y-intercept. Set x equal to 0, get 7/5 of the negative variety. Vertical asymptote. Denominator equal to 0. And in this case, I'll have negative 5, positive 1. Horizontal. So I have x to the first on top, x squared on bottom. If the degree of the numerator is less than the degree of the denominator, 0 is my horizontal. Sketch what we know. So I have an x-intercept of negative 7. have a y-intercept of negative 7/5. Put some dots there, dot here. Asymptote, negative 5, positive 1. And now here's also a case I have a horizontal asymptote at 0. So here's that case I was talking about. We actually do have a point on a horizontal asymptote, which is fine because, once again, horizontal asymptotes only describe end behavior. So now we're going to start plugging some stuff in a moment, but first I can tell you that the bottom portion or the middle portion of this graph has to all be below the x-axis because there is no x-intercept calculated in this middle region. So it's got to come up at some point and come back down. Where exactly that happens, I don't know, and I don't really care at this point. Now, here's a situation. I know nothing about either right side being above or below, and left side, I don't know if it starts here, crosses, and then comes back down, starts here, hits at one point and stays below, or comes up, hits at one point, stays above, or crosses back down. So I actually need to plug in 3 values in this case. All right? So let's go ahead and do that. I'm going to plug in f of negative 8, f of negative 6, and f of 2. All right? And I'm going to plug into the factored form of the equation. When I plug in a negative 8, I get a negative, negative, and negative, which is a negative. So that means in this area, I get a negative value. So it's got to approach this line right here. At negative 6, I get a negative, or a positive on top, sorry, and 2 negatives on the bottom, which means I have a positive value. So at negative 6, since it's positive, it must come from the top, cross under, and then approach that line as x gets very, very big. Now at 2, I get a positive on top. In the bottom, I get a positive and a positive, which again is a positive. So I know that this graph always stays in the positive region because it never crosses the axis. All right? A couple more. So in this case, we're going to take and once again find our x-intercept by setting y equal to 0, 5x equals 0, and x equals 0. So now we set x equal to 0 for the y-intercept, and we get y equals 0. Factor the denominator. Unfortunately, this doesn't factor. So if I set that equal to 0, you'll notice we'd have, where does x squared equal negative 1? Never happens, so there are no vertical asymptotes. Now, I look at the degree of the numerator for the horizontal, and that's 5x to the first. The bottom is 1x squared, degree of the numerator less than the degree of the denominator, y equals 0, is my horizontal asymptote. Let's go ahead and sketch some things out. I have an x and y intercept at 0, and I also have, once again, a horizontal asymptote at 0, which is totally fine. Now this is a bit odd since we don't have any vertical asymptotes to gauge with, but when we've had that situation before, we've actually plugged in numbers. So I'm going to take and look at negative 1, and I'm going to look at positive 1 in this function. So when I plug in a negative 1, you'll notice in the top I get a negative, in the bottom I get a positive, which gives me a negative value. So what that says is it's going negative, but then approaching that horizontal line. On the right, I have a positive over a positive, which equals a positive. So this goes above and then comes back down and approaches that line. So a little bit different kind of graph here. All right, last example. This has got some factoring involved in it. We're going to pull out a 3 from the numerator. You get an x squared minus x minus 12. And then we've got on the bottom, we've got an x plus 2 and an x minus 1. Keep going here, we've got a 3, x minus 4, x plus 3, and then still our x plus 2, and x minus 1. Alright, so if this is our case and we want to find an x-intercept, set y equal to 0, notice I'm not going to go through writing the whole problem out again. The denominator has been multiplying out every single time, so the numerator will have to be set equal to 0 and solve. So I get 4 and negative 3 as my x-intercepts. My y-intercept is going to be pretty large. It's actually 18, 36 over 2. Vertical asymptotes, set the denominator equal to 0. So I have 0 equals x plus 2, x minus 1. I get a 1 and a negative 2 for my values there. And in the horizontal, in this case, the numerator, 3x squared, my leading coefficient and my degree, 1x squared, leading coefficient and degree, so y equals 3 is that horizontal asymptote. So let's go ahead and graph this. And again, it's going to be a sketch because I got this big number of 18 thrown in here. So here we go. Here's a y-intercept up at 18. Call this 18. We've got an x-intercept at 4. Let's make this 4 and negative 3. Vertical asymptote at 1 and negative 2. Let's throw these guys in here. And then a horizontal asymptote at 3 again. Okay, and I know a lot about this graph. Here's what I know. In fact, this is going to take very little work to do. Since it goes through the axis at 4 and has to approach this line, it's got to look something like this. And then as x gets very big, it's got to approach the horizontal asymptote here. Now, in this innermost region, the middle region, it never crosses the axis because I don't have any calculated x-intercepts. So I know that this graph has to look something like this. It could go down more, but it doesn't really matter. It's a sketch. But it's not going to cross the axis here. Then, on the left side, again, it crosses this axis, and it's got to approach these two asymptotes. And my graph's done. That was actually the easiest of all. So you got a little bit of work to do tonight. Fill out your summaries, go to my math lab, answer the questions, and we'll see you tomorrow.